Welcome to you all in my second video of conditional trigonometrical identities. Before starting, I want you to make sure that you please subscribe my channel if you have not already subscribed, so that I will be encouraged to make similar videos. Also press bell icon so that you will be informed about my coming videos. So now, without delay, I am going to prove some important trigonometrical identities, conditional trigonometrical identities. So up to two questions we completed in last video. Now I'm starting from third question. If a plus b plus c equals to pi radian, then we have to prove that minus sine a plus sine b plus sine c equals to 4 cos a over 2 sine b over 2 sine c over 2. Let's start this from left hand side. LHS equals to, we can write this as sine b minus sine a plus sine c, and we can use sine c minus sine d formula, and the formula for sine c minus sine d is sine c minus sine d is 2 cos c plus d over 2 times sine c minus d over 2. We have this formula for sine c minus sine d. So using that formula, we can write this as 2 cos b plus a over 2 and sine b minus a over 2 plus sine c. And now you know that a plus b plus c equals to 100 degree. Pi radian means 100 degree. So a plus b equals to 100 degree minus this plus c goes there and becomes minus c. And now if you divide both sides by 2, a plus b over 2 equals to 100t minus c over 2. That is 100t over 2 is 90 degree minus c over 2. So taking a cos on both sides, cos a plus b over 2 will be cos 90 degree minus c over 2 is, that is sine c over 2. Okay, so this cos b plus a or a plus b, same thing. So cos b plus a over 2 equals to, we can write sine c over 2. And now this equals to, we can write 2 sine c over 2. Here is sine b minus a over 2, and sine c also we should express in this term, and sine c formula is 2 sine c over 2 cos c over 2 we can write. And now here sine, we have used this formula, that is sine theta formula, sine theta formula in terms of sub multiple angle, that is 2 sine theta over 2 cos theta over 2. Okay, so using that formula, we have written sine c equal to 2 sine c over 2 cos c over 2. And now from these two terms, we can take out sine c over 2 common. 2 sine c over 2 is common, and we have here sine b minus a over 2 plus 2 sine c over 2 already common. So here is cos c over 2. This equals to 2 sine c over 2. Here sine b minus a over 2 plus, here if you take sine on both sides, then sine a plus b over 2 will be Here if you take sine on both sides, that sine a plus b over 2 equals to sine 90 minus c over 2 will be cos c over 2. So this cos c over 2 can be replaced by sine a plus b over 2, or sine a plus b over 2 is same as sine b plus a over 2. Okay, sine b plus a over 2. So a plus b is same as b plus a, so I have written b plus a to make pattern same like this. So now 2 sine c over 2, and this you can write it first, sine b over 2 plus a over 2, and this you can write in second place, plus sine b over 2 minus a over 2 enclosed by curly bracket. Now we can use formula of sine a plus b plus sine a minus b. You know that formula, that is sine a plus b plus sine a minus b formula is 2 sine a cos b. Okay, so using that formula, in place of a we have b over 2, in place of this b we have a over 2. We can write this equals to 2 sine b over 2 cos a over 2. So from this expression we will get 2 sine c over 2, this becomes 2 sine b over 2 cos a over 2, and this equals to 2 to the 4 cos a over 2, this sine b over 2, and at last we have sine c over 2. 4 cos a over 2 sine b over 2 sine c over 2, which is our RHS, equals to right hand side proved. Okay, in this way this conditional problem trigonometrical identities we have proved. Okay, so if you need to write this, then you can pause the video and copy it. Now I will move to next question. Our next question is sine 2a plus sine 2b plus sine 2c equals to 4 sine a sine b sine c we have to prove. So let's start from left hand side. So left hand side equals to we have sine 2a plus sine 2b plus sine 2c. This is our left hand side. Okay, and here we can use sine c plus sine d formula. In place of c we have 2a, in place of d we have 2b. Okay, and the condition is same for this also, because it is also the conditional trigonometrical identities. And here on the side I am writing the formula of sine c plus sine d, that is 2 sine c plus d over 2 and cos c minus d over 2, and using that formula we can write 2 sine, in place of c we have 2a, in place of d we have 2b, so 2a plus 2b over 2 cos 2a minus 2b over 2 plus we have here sine 2c, and this equals to 2 sine. So 2 from numerator will be common, and that 2 and this 2 will be cancelled. So we can simply write a plus b here. Cos, here also 2 will be common, and that common 2 and this 2 will be cancelled. So we can simply write a minus b here plus here we have sine 2c. And as you know that a plus b plus c is given pi radian, that means a plus b plus c equals to 100 degree, pi radian is 100 degree, and a plus b equals to 100 degree minus c. So taking sine on both sides, sine a plus b equals to sine 100 minus c is, that is sine c. 100 minus c lies in second quadrant. In second quadrant sine is positive, so here we have written positive sign, and this 180 you can write as 90 times 2. So 2 is the even number, 180 is the even multiple of 90. So if you take sine, then this trigonometrical ratio sine does not change, sine remains sine. Now 2 sine a plus b, from here we have already got that, that is sine c times here is cos a minus b plus here is sine c, so to take out common, this also we can express in terms of sine c. So sine 2c formula is 2 sine c cos c, 2 sine c cos c, because in previous question also I have written sine 2 theta formula is 2 sine theta cos theta. And now from this and from this we can take out common, 2 sine c is common, and we get inside there cos a minus b plus cos c. Now if you take cos on both sides, here cos on this a plus b equals to 100 minus c, if you take cos on both sides, cos a plus b equals to cos 100 degree minus c, and this implies cos a plus b equals to cos 100 degree minus c. In second quadrant cos is negative, and 180 is the even multiple of 90, because 180 equals to, we can write 90 times 2, 2 is even, so cos does not change, cos c becomes, but as cos lies in this, as this 180 degree minus c lies in second quadrant, it is negative, cos is negative in second quadrant, only sine and cosec is positive in second quadrant, so it will be minus cos c. And if you multiply both sides by minus sign, then minus cos a plus b equals to cos c. Okay, we get cos c equals to minus cos a plus b, so this cos c can be replaced by minus cos a plus b. This equals to, sorry, 2 sine c, here is cos a minus b minus cos c equals to minus cos a plus b. Okay, and next to that we use our next formula, that is cos a minus b minus cos a plus b. Formula is 2 sine a sine b. We have this formula for cos a minus b minus cos a plus b, so we can use this formula for these two terms. So this equals to, we have 2 sine c, this is equals to 2 sine a sine b. Now we can multiply this 2 into 2 to the 4, 4 Sine A, sine B, sine C will get, which is our right hand side, equals to right hand side proved. Okay, in this way we have proved this important conditional trigonometrical identity. So if you need to copy it, you can pause the video and copy it comfortably. And now I will move to next question. Okay, we have question sine square A plus sine square B plus sine square C equals 2. We have to prove 2, 1 plus cos A, cos B, cos C. Let's start from left hand side. We can multiply numerator by 2 and divide by 2. 1 over 2, we can write 2 sine square A plus 2 sine square B, and we can write this last one without multiplying by 2 and dividing by 2. We can write like this way because from this 2 will be common, then that 2 common will be cancelled with this 2. So this and then this one is same. And now our formula for 2 sine square A is, we know that the formula for cos 2 theta is 1 minus 2 sine square theta. So from this we can make one formula, that is 2 sine square theta, when it comes here becomes plus, equals to 1 minus cos 2 theta. Okay, so 2 sine square A equals to, we can write 1 minus cos 2A. 1 over 2, this is 1 minus cos 2A, plus this is 1 minus cos 2B, plus sine square C at last. This 1 over 2, 1 plus 1 will be 2, minus cos 2A and cos 2B. Minus can be taken out common from this 2. Cos 2A minus dash minus plus cos 2B. Okay, we can write like this way, plus here is sine square C. So 1 plus 1 is 2, minus is common from this 2, and cos 2A minus dash minus plus cos 2B. Okay, and now this 1 over 2 multiplies inside, 1 over 2 times 2 minus 1 over 2 multiplies here. There is nothing, means there is 1. So 1 over 2, 1 over 2. Cos 2A plus cos 2B. We can use cos C plus cos D formula, that is cos C plus cos D formula is 2 cos C plus D over 2 and cos C minus D over 2. Okay, so in place of C we have 2A, in place of D we have 2B. So it becomes 2 cos 2A plus 2B over 2 and cos 2A minus 2B over 2 plus sine square C is at last there. Now 2 and 2 can be cancelled, and this 2 and 2 can be cancelled. So here we have 1 minus, here 2 common comes out from this, that 2 and this 2 will be cancelled. So we can directly write cos A plus B. From this also 2 common comes out, that 2 and this 2 will be cancelled. So we can write cos A minus B plus, here is sine square C. Okay, and now as it is given that A plus B plus C equals to pi radian is 180 degree, and A plus B equals to C goes to other side and becomes 100 degree minus C, or subtracting C on both sides also we can say. And here cos A plus B equals to cos 100 degree minus C, that will be minus cos C. Okay, as I have already explained, that is 180 minus c lies in second quadrant, so in second quadrant cos is negative, and as 180 is the even multiple of 90 times 2 we can write for 180, so 2 is even, so cos ratio does not change, cos remains cos. And now here we have 1 minus cos a plus b, from there is this equals to minus cos c, and we have already this cos a minus b plus sin square c, same 1 minus times minus plus cos c and cos a minus b, and here is cos c, so to take out common we should also change this in terms of cos, so sin square c formula you know, that is 1 minus cos square c. Okay, because you know that formula of sin square theta equals to 1 minus cos square theta. Okay, using that formula we can write sin square c equal to 1 minus cos square c, and now 1 and 1 when added it becomes 2, plus from these two cos c is common, and now here is cos a minus b left, and here is minus cos c left, and now 2 plus cos c, and here if you take this case, minus cos c is cos a plus b. Okay, so minus cos c can be replaced by cos plus cos a plus b. So here we have cos a minus b plus minus cos c is plus cos a plus b, and we have a formula for cos a plus b plus cos a minus b. Cos a plus b plus cos a minus b formula is 2 cos a times cos b. So using this formula cos a plus b plus cos a minus b cos 2 cos a cos b, what we can write is we have 2 plus cos c, this will be according to this formula 2 cos a cos b equals to 2 is common from both, 1 plus cos a cos b cos c, which is our right hand side proved. Okay, in this way we have proved this important conditional trigonometrical identities problem. I hope that this video is helpful to you. I suggest you to watch this video once and practice without looking it, and if you have anything difficult in the middle you can watch it again. And if you are new to my channel, please do not forget to subscribe my channel so that I will be encouraged to make similar type of videos, and also press bell icon so that you will be informed about my coming videos. Thank you for watching once again. Thank you very much.